Waf.
Hey, K-Means Carly.
So now let's dive into confidence intervals even further by looking at confidence intervals for means instead of percents.
Oh, means, just like K-Means.
Yeah, my fave. So means often come up in surveys as well as percents. It says sometimes we want to look at surveys with numerical answers, like maybe how many hours did you sleep last night?
Oh, not enough. Only like 7.
Oh, I was 4, so definitely not enough. How much money did you make last year?
Not
You
enough.
probably don't want to answer that question. Or how much do you weigh? And
Too much.
In these surveys, the relevant statistic isn't the percent, it's actually the average. So now we're going to be interested in looking at the expected value and standard error of the sample average or sample mean. So it says basically we're doing exactly what we did for percents, except we're dealing with the sample average instead of the sample percent. And the population mean, which we represent as mu, is unknown. However, we do know our sample mean, which is x bar. So if I did a really quick visual, basically we would have some giant population, and we would want to be figuring out what is the mean mu of that population. But we don't know what it is. So instead, we can take a random sample and get some sample mean, x bar, and use that as an estimate for the population mean. So with this puzzle, we're going to talk about WAF's absolute favorite thing, money.
Money. I don't have enough of it.
Yes. So thinking of your own situation, how much money per year would you need to make in order to consider yourself rich?
Oh, that's a good question.
Yeah, so this was a survey that was done. It says a random sample, good, random sample, I can use all my formulas, of 1,572 adults nationwide was taken. And their average, so this is our sample average, x bar, sample average was 150,000. And the sample SD was $158,600.
Wow, so the SD was larger than the mean.
Yeah, which is kind of crazy. This means that the spread was pretty big for this answer. So I am going to just answer these questions in order. It says estimate the average amount of money that all American adults would need to make to consider themselves rich. Well, that is just the expected value of the average, which is just the average that we got, which was estimated to be 150,000. So the expected value of the average is very simple, just like the expected value of the percent.
So you're saying if we ask half of any random person when the survey was taken, out of anyone in America, we expect half of them to say less than 150,000 to be considered, for them to consider themselves rich, and half of them to say more than 150,000?
Yes.
Awesome.
So that is our expected value. And next this is to calculate the standard error, because that is an estimate. That's what we got in our sample. But maybe if we took another sample, we might not get 150,000. Maybe we get 148,000 or another number. So the standard error is going to help us measure that uncertainty. So the standard error for the average is just the standard deviation divided by the square root of n. And the standard deviation in our sample is 158,600. I'm going to use that as an estimate of the standard deviation of the population because we did a random sample, and n was 1572. So WAF.
So 158,600 divided by 1572 square rooted is $4,000.
Sounds good. We're going to round to $4,000. So now I can use these two numbers to give a confidence interval for the mean. So part C says, what is an 85% confidence interval for the average amount of money all American adults would need to make to consider themselves rich? So to find an 85% confidence interval, I'm going to take that sample average, my sample average, which I know was 150,000, and I want to make that into a range. So I'm going to add and subtract the margin of error, which is just my z-score times my standard error. So I have my standard error, which was $4,000. I just need to go ahead and find my z-score. So because we're dealing with averages, I know the central limit theorem is going to kick in. The distribution is going to look roughly like the normal curve, and we basically want 85% in the middle. So we said you can do this multiple ways. I like thinking about what are the two tails. So 100 minus 85 is 15. So each tail is 7.5%. So I can go ahead and to find this z-score, I can do norm.ppf of 0.075 to get my z-score.
And I get a z-score of negative 1.44.
1.44. And that is the negative version. The positive version would be the other z-score. So I can find this confidence interval by saying I have $150,000 as my sample average. I'm going to add and subtract 1.44, which is my z-score, times my standard error, which is $4,000. And that's going to give me my 85% confidence interval.
So I'm first going to do the bound where I do the minus. So I get $144,240 when I subtract. And when I add 1.44 times 4,000, I get $155,760.
$760. Perfect. So I can interpret my 85% confidence interval by saying I am 85% sure that if I sampled all US adults and asked them this question, their average would lie between about 144,000 and 156,000. So that is the confidence interval for the mean. And the last question asks us, would a 95% confidence interval be wider or narrower than an 85% confidence interval? So in other words, is the margin of error going to be bigger or smaller? So for the 85% confidence interval, we know that we are going to take our sample average, which is 150,000, plus or minus my z-score, which was 1.44, times my standard error. And this again is called the margin of error. So the question is our margin of error bigger or smaller for a 95% confidence interval? So for a 95% confidence interval, I am also going to take our sample average, 150,000, and I'm going to add and subtract some z-score times my standard error.
So if I remember you telling me, the 95% confidence interval has this nice z-score of exactly 2?
Yes, exactly. It's technically 1.96, but I always round it to 2. So the margin of error for the 95% confidence interval is actually bigger than the margin of error for the 85% confidence interval. So to answer this question, would the 95% confidence interval be narrower or wider? It would definitely be wider. The more confident we are, the wider our confidence interval is going to be. So we've seen how we can create confidence intervals for percents and for means, and how it's the same kind of format to do that. And this can help us answer the question of how can we make the best inferences to predict what we don't know about the population from a random sample.